everyone, in this video we are going to determine the probability given a two-way table. This is the second part. I will put the link of the first part in the description box below. The difference between the first and this part right here is that in this table everything's empty. So there are no given values that we have here. However, in this word problem that we have on top of this table, we are given the numbers that we can put in to fill this table in with values. So let's start going through the problem here. It says that there are 300 people that were asked in this survey, and they were asked either they are left-handed or right-handed. Of these respondents, 170 of them were female. So the grand total here, looking at this problem, we have 300. It's the grand total. Now, it says that of these respondents, 170 of these are female. So the total female is 170. So this number goes here. And then in the next statement, 140 of these are left-handed. So 140 of these are left-handed. We don't know if it's a male or female, but the total for left-handed is 140. Now, the next given that we have here, 80 of these female respondents were left-handed. So 80 of these 170 were left-handed. So this is 80 right here. And after that, we say we can also say that there are 70 of these male respondents were right-handed. So 70 over here. So we can determine the rest of them. So in order to do that, we always remember that we take the total for all the columns should be the ones that located at the bottom, and the total that we have here should be 300. So we cover one after the other so we can determine the rest of these blank cells. So we start with this. So if I were to cover this part right here, so the grand total is 300 and we got 170. That means this one right here is 130. So I'm using red just to make sure that we get a difference between what are those given and what are the ones that we need to determine. So second, we have here on this column right here, we say that the total is 130, but then we only have 70. So that means this side right here should be 60. So that if you have 70 plus 60 is 130. Now let's move on to the next one right here. Let's check this part right here. So if I have 60 plus 80, and that is equal to 140. So we're good with this row right here. Now let's move on to the this column is correct. So let's move on to this second row right here. We have a 70 and we're supposed to get 100 and we have an 80 and we're supposed to get 170. So what should we put over here? So this one has to be 90. So that if we add 90 plus 80 is 170. And then from here, we can add these two up, and this should be 160. And we can check if they match up, because if we have 160 plus 140 is 300. So if we check each of the columns, we are good now. So again, that is 60 plus 70 is 130. 90 plus 80 is 170. 160 plus 140 is 300. Going through each of the columns here. Columns, so 130 plus 170 is 300. 60 plus 80 is 140. 70 plus 90 is 160. So we're good. So we are now ready to determine these probabilities. Let's take the first one here. So what is the probability that you ask a female and right-handed? So I'm just going to represent right-handed as R, left-handed as L, and then male as M, female as F. So in this problem right here, we're looking for the probability that we are able to ask a female and they are, and then that female is right-handed. So I'm just going to write R. So for probability of and, these are and right here over the grand total. So female and right-handed. So the intersection for female and right-handed is, that's going to be 90. So female and right-handed. So that is 90 over the grand total is 300. So if we divide, that's 300 right here. So if we are going to divide this to come up with a fraction, this is 0.3 or 30%. So 30% of the time, you will be able to ask a female and at the same time, right-handed. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. So we are asked for the probability that you are able to ask a male. So that's a probability that it's a male and left-handed. So that's L. So that's the intersection between a male and left-handed, and that is 60. So that would be 60 over the grand total, 300. So that would come out, you can take, this is the final answer right here in fraction, but if you divide it to get the proportion, that would be 0.2, or in percentage, it's 20%. Did you get 20% for this problem right here? Good. Perfect. Now let's move on to the next examples here. What is the probability that you ask a male or right-handed? Again, I'm going to take the formula for or up here. So this is the formula for or. So to set up the equation here, it's going to be probability that we ask a male or right-handed. So that is male or right-handed. So first, probability of A. So our A now is male and our B is right-handed. So we start with A, so that would be a male. The probability that it's a male would be the grand total for the male. That would be 130. So I'm going to write 130. That's the probability of a male over 300 plus the probability of B, which is right-handed. So right-handed would be 160. So that's 160 over 300 minus the intersection between these two. So we are looking at male. So this is the row that we're looking at, and then we are looking for the right-handed. So right-handed column is this. So we're looking for the intersection between these two pens. They intersect here, and that number is 70. So I go ahead and write minus 70 over 300. So then we can add these two together. 130 plus 160 minus 70 should be 220 over 300. Or we can we can change this to its proportion or decimal version. That would be 0.73 or 73%. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we go over the problem here. So we're looking for the probability that you ask a female or that's left-handed. So our A is probability of the female is 170. So that's 170 over 300 plus probability of a B, which is the left-handed. So it's going to be 140. So that's 140 over 300 minus the intersection. So if I have a female, so the female is this row right here. And then we have left-handed. Left-handed is this column right here. That means that they're intersecting at this cell right here, which would equal to 80. So that is, the intersection would be 80 over 300. So then we add these two together. 170 plus 140 minus 80 is 230. So that's 230 over 300. And so this is the answer right here. Or we can change this to decimal. That would be 0.77, or in percent, 77%. Did you get the same answer as this? Good. Perfect. Now let's move on to the next example here. We are looking for the probability that you ask somebody who is not right-handed. So this is a complement. We use the rule of complement for probability. So we go ahead and say probability of not right-handed. So not R. So there are two options only. So if it's not R, that means it's left. So if we're not looking for right-handed, that means we're looking for the left-handed. So we go ahead and say that's the probability of left-handed. So in this problem right here, we have probability of left-handed is 60. So, oh no, that's only for the male, but we want the total. So that would be 140 over 300. Again, the total for the left is 140. The grand total is 300. And then this is the answer right here. We can express this in decimal. And this is 0.47, or in percent, 47%. And then we can use the other equation right here, 1 minus, since the probability, the total probability is 1. And so we can minus it from the probability that it's right-handed. So that's minus 160, that's right-handed, over 300. So then we multiply this by, we can multiply this by 300 times 300. So we can get a common denominator. So that's 300 over 300. So that comes out to be 300 over 300, which is just pretty much equal to 1 minus 160 over 300. So we have 300 minus 160 is 140 over 300. So pretty much they are just the same. So this is also 0.47 or 47%. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we're asked for the probability that we get a female. So pretty much it's the total of all the female. That would be 170 over 300. Or this is the other one, that we've used the complement. This is not male. So we're looking for not male. So then we can go ahead and say 170. We can take this as the final answer right here. But we can change this to decimal. It should be 0.57 or 57% of the time that we are able to ask a female respondent. Did you get the same answer as this? Good. Perfect. Now let's move on to the last example here. So first problem here. What is the probability that you ask a male respondent given that he is right-handed? So in this problem, we say probability that it's a male given that, again, this vertical line is read as given that he is right-handed. That's R. So to do this, again, there was a trick that I give you from the other video. This bottom here is the total of the right-handed, and of these right-handed, how many of these are male? So in this problem right here, the total of right-handed is 160. So I write 160. And then of these 160, how many are male? And that is 70. So this is already the final answer right here. Or we can again change this to decimal. That's 0.44 or 44%. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, and pause it and check your answer. Okay, so we're asked for the probability that we are able to ask right-handed. So it's a right-handed given that the respondent is a female. So it's pretty much the same thing that we did over here. That's the total of the female, which is 170. So this, again, the bottom here is the total of this. Let me put the red pen over here so we know what numbers do we put in there. So that's the total of the female is 170. And then of this 170, how many of these are right-handed? So of this 170, how many are right-handed? And that is 90. So this is the fraction that we have. So that means of the 170 female, you get the chance to ask 90 right-handed. So we can go ahead and simplify this into its decimal version. This would be 0.53 or 53% of the time. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!